This is the lesson for Mod 4, Lesson 5, Vertical and Horizontal Asymptotes. In this mod, we're going to be looking at graphs of rational functions. Lesson 5 is going to be focusing on asymptotes. So the goals of this are going to be to find the domain of a rational function, which we did quite a bit of in the last mod, to determine vertical asymptotes for a rational function, and finally to determine horizontal asymptotes for a rational function. So a couple definitions we're going to see throughout the next couple sections. So one is a rational function. So we've done a lot with rational expressions, adding, subtracting, multiplying, dividing. A rational function is where we're really going to see this whole f of x and looking at the graphical relationship for a rational. So these are some examples you can see. So we have f of x is 1 over x, g of x, h of x. Notice that all of these are fractions and there's variables in the denominator. That's going to be kind of a common theme you're going to see throughout. The first thing we're going to focus on are vertical asymptotes, and those are, you might remember graphing vertical lines back in Math 1. So a vertical line that a graph approaches or guides the behavior of the function, and this can be found using the domain, right? So you're going to see a lot of times there's a correlation between the domain and vertical asymptotes. For these problems, you're going to have, for example, f of x equals 1 over x. That's this function right here. And we learned in the last mod that we can find our domain, and that would be setting the bottom equal to 0. And we would get x, basically x cannot equal 0. That's our domain. Now, if I look at x equals 0 as an actual line on a graph, that would be this vertical line right here. And you can see in the graph what happens is that creates an asymptote. So as the graph comes very close to that 0, it doesn't actually ever cross that line. It goes into positive or negative infinity. So the closer that this gets to that 0, it kind of goes off into those infinities. So our vertical asymptote is actually going to be x equals 0. So you can see instead of like if they're asking, is there a vertical line that the graph cannot cross, and it's going to be tied very closely to that domain. Same idea with g of x. If I was to do the domain, we know that x cannot equal 0 for the domain. Or I'm sorry, x cannot equal 1. And if I look at 1 on my graph, same thing. I have this vertical line. As the graph becomes closer, it goes into positive and negative infinity for the y. And our vertical asymptote, again, is going to be the same as almost the same as the domain. So x equals 1 is our vertical asymptote. The graph never touches that line. Finally, for the last one, same idea. X equals negative 2, or cannot equal negative 2 is our domain. And if I look at negative 2 on my graph, that's again my asymptote. As it gets closer to that line, it goes into positive or negative infinity for y. The second topic we're going to see are horizontal asymptotes. So horizontal lines, again, go left to right, and this is kind of the same idea. So horizontal asymptote is really, it approaches and guides the behavior of the function. So as we go to positive and negative infinity for the end behavior, it'll approach those asymptotes, right? So a lot of times this is more associated when we talk about end behavior for a rational. And so when we look at this, we're going to see there's a couple cases. So we don't have to really calculate it as like setting the bottom to 0. It's a little bit different. So one case we can have is where the degree of the numerator is less than the degree of the denominator. So an example would be like if we have f of x here. Same thing as before, right? We have our domain cannot equal -1. Our vertical asymptote would be -1. And you can see on the graph that kind of connects with what we already did. And then we're going to see our horizontal asymptote, the degree of the top. There's no x on the top, so really it's a degree of 0. The bottom has a degree 1. So it's like we really are just kind of looking at the bottom has a degree of 1. The top has a degree of 0 because there's no x's there. And since the bottom is bigger, it's always going to go to 0. So if I look at this on the graph, at y equals 0, which is right here, you can see as it goes to positive and negative infinity, it's getting close to that line, but not quite touching it. So it's getting really, really close to that y equals 0. So anytime there's a degree on the bottom that's bigger than the degree on the top, your answer is always going to be the horizontal asymptote is y equals 0. The third case, or the second case we'll have, is when the degree of the numerator or the top is the same as the degree on the bottom, right? So this is like a one-to-one relationship almost. So everything else is kind of the same deal, so I can set the bottom to 0 if I want to get the domain. So I'll get it cannot equal 5/2 because you would add and divide. So that part's not anything too different than we saw in the last mod. I'll maybe make it at 2.5. We're going to have a vertical asymptote of 2.5. And then our horizontal asymptote, we're going to look at, we see there's a degree of 1 at the top and bottom. So when I look at this, I'm really just simplifying 6x over 2x. So when I do 6x over 2x, because these cancel, I get 3. So my horizontal asymptote is y equals 3. So when the degree on the top and bottom is the same, it's just a ratio of the coefficients. So if I look at, you can see 3 has this horizontal asymptote. This was our vertical asymptote. And then the graph is like kind of has this symmetry where it goes each on a little piece of that graph. The third case, and we're not going to see too much of this case for this kind of shorter mod, but this last case is if the degree on the top is greater than the degree on the bottom. So for example, if I have h of x and the domain and all the other stuff would be exactly the same. So it cannot equal -2 in the domain, which means we have a vertical asymptote at -2. But we can see when we look at our graph, there's an x3 on the top and an x on the bottom. So what that means is the top is going to get bigger much faster than the bottom, which is going to not have any type of asymptote for the horizontal. And so the horizontal asymptote, you would just say there's none, or there is a 1. And you can see that the end behavior, it goes off to positive and negative infinity. So it doesn't, the end behavior doesn't go approach a number, so that's why we don't have one. So if it's bigger on top than it is on the bottom, there's not going to be a horizontal asymptote. All right, so for these examples, it's really just calculating and identifying. So, and we're going to see this a lot in the next couple sections when we graph. So for our domain, what we always want to first do is see if we can factor. The two examples here, or the first one, we don't have to factor anything, but I might check if I can factor. I can't factor the top or the bottom. And so my domain, I would just take my opposite. And so my domain, like we've been practicing, is we know x can't equal 3 because that would make the bottom 0. The vertical asymptote then is x equals 3. The horizontal asymptote, you could see that on the top we have a degree of 0. On the bottom we have a degree of 1. And so the bottom is going to get much bigger than the top, and so that's going to be our first case where y is equal to 0 because the top is going to stay at 5 and the bottom is going to get much larger. So this is going to be like that first case we saw. For number 2, same idea. I'm going to see if I can factor maybe first. The top doesn't factor, so I'm going to rewrite it. The bottom does factor, and that's like, again, you have a trinomial, so factors of 6 that add to 5. You maybe need to make a table, maybe you don't. At this point, we've kind of done it for a bit. So hopefully you got it to be 2 and 3. And so now I'm going to find my domain first. So if I take the opposite signs here, I'll get that it cannot equal -2 or -3. Nothing cancels. My vertical asymptotes then will be the same. So x equals -2 will be a vertical asymptote, and so will x equal -3. And then my horizontal asymptote, you can do a few ways. You can look at your factored answer. I always think it's kind of easier to go back to the original, and I see that I have the same degree on the top and bottom, x squared on top, x squared on bottom. So if I do 3x squared over x squared, I get 3. So my horizontal asymptote is y equals 3. And this was the same as when we did the cases. This was the same as case 2. You don't have to list the case, but just so you know where that came from. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.